think we are ready to start.
Yeah, it's going.
Okay.
Hello everyone, I'm Ahmed, and today I'm going to present my master's thesis work. My master's thesis work was under the topic design and implementation of an expert system for monitoring and management web service industrial applications. My major is factory automation, and my minor is microsystem. My supervisor is Dr. Andrea, is not here today. And the project was funded by Factory Lab under a project named Code Plan Cockpit. Let's go. First thing is the contents. The first point we are going to speak is the problem statement and what is the proposed solution for this problem and the thesis work. Then we are going to see our case study, which we are going to apply our solution for this case study. And then the next 3 points we are going to speak about the web service, the definition of web service, what is the advantage of them, and why we should use them, and then actually how we can design a web service. And then the next 3 points we are going to speak about the expert system. It's the same, what is the expert system meaning? We are going to talk about something called KPI, key product indicators, which we are going to program the expert system to use them. We are going to speak about the implementation and result of this expert system. And finally, we are going to see the conclusion and future work. So first, the problem statement. Our problem was that we have a lot of automation system in every factory. They have old automation system like PLC, and now we need to integrate them to current technology like web service. This was the first part of the problem. The next part of the problem, we need to process this data which is coming from this web service with some intelligent or smart system. So actually my thesis work was divided into 2 parts, and this is what I'm going to show today. So the proposed solution was first, we didn't need to interrupt the work at all during for this, let's say we have a factory or something. We don't need to interrupt the work at all, so we're thinking we are not going to change the old system like the PLCs and all this stuff. We are going to add a new controller to this system which is able to integrate the old technology to web service technology. And we are going to follow ISA 95 model for implementing this technology. So inside ISA 95, there is many layers, and every layer there is some definition for the purpose of the layer, what we should do in this layer. So in level 2 and level 3 I'm going to work. In level 2 this is which I'm going to implement my web service. It's more like automation level. Here we are going to make kind of monitoring system which is going to show all the technical data which coming from this production line or our case study actually. And then on the 3rd level we are going to have some management system which is more oriented to business, let's say. So here the business guy or the manager guy need to see production data. He cannot see, or he don't have a lot of things to do with technical data. He needs to see more production data. And we are going to design something called the XML event. We are going to talk more about it. We are going to follow also another standard called CAMX. We are going to make some analogy between CAMX and between our XML events to make it more like more trusted events. Also, I'm going to define these KPIs, some KPIs, and then I'm going to translate them to some rules to program the expert system built on these rules. And this is our case study. This case study here in the other lab in front of us. It's kind of a small factory. The target of the factory is to assemble small cylinder bases. It has 6 machines inside. One of them is a robot, and it's like the first machine here. You can see it, which here it should be in this place. It's like distribution. It's distributing the work pieces. Then it goes to something called testing. The testing just tests the length of this work pieces. Then it goes to the conveyor and they take it by this handling station. They give it to this station, which is processing station, and the processing station will make kind of drilling for it, and it will pass it for the robot by the handling station for sure, and the robot is going to assemble it, and finally it's going to be inside the buffer or the warehouse. Okay, now we are going to speak about the web service. The web service definition, as we can see, is a software meant to support the interaction between two machines. It's based on something called WSDL, web service description language, and the core of this web service is SOAP. SOAP messages, let's say. SOAP is kind of, let's say, it's a stack of protocols. This stack is has a core of it like XML messages. The XML is stack of this, as it's clear here, and it make translation of this message using HTTP. And then we are going to speak here why we are going to use the web service. The web service has those kind of advantage. We can speak so fast about them. First thing, it's a self-contained application, and it's independent from the language of operating system. It means that you don't need a certain operating system for operating this web service. You just need a client, HTTP client, and HTTP server. So here you are not bounded by any operating system. Second thing is self-scripting language. As we said, it's based on XML, and XML is like kind of text language. Third thing is encapsulated and it's integral. You can think about web service as it's a big picture, and you are collecting it. There is some client and there is some provider, and the client can collect the whole picture from many different providers. Like it's a kind of puzzle, let's say, and you collect it. So every provider you can provide some services, and the client subscribes to service from those providers. Interoperability is the same issue like self-contained application. Here it's like interoperability is means like the web service can work in any system. It can be discovered and dynamic language. Inside the web service design, you use something called UDDI protocol. This UDDI protocol allows you to publish your service, and also it's you can subscribe it or see it online. You don't need actually to make anything more than discovering it. It's open source. All the standard we are going to use to design our web service is open source. You don't need to pay any money for them. You can just go to the internet and see these standards. This is XML example because we are going to deal with XML in our project. It's like the same kind of object-oriented programming. If someone knows object-oriented programming, you have some object and you have some instance from him. So this object, let's say we have some object called customer, and this customer has some date, let's say, and it has some address, and actually you can generate 1,000 customers from this one. So what we are going to do actually in our project, we are going first to design this thing which is called XML schema, and we can generate many messages from it, or many instances from it. And now in designing the schema, I have selected, or I have created 3 objects. I create some object called labor, I create some object called workpiece, I create some object called station. And every object has some properties. like the labor should have some station ID. This is the station which the labor is working on it. It has some time stamp. This time stamp for every time the labor is going to do something, it should have some stamp to tell which time is going to do this action. It has ID, it has labor action. And it's the same for everything. So with work piece would be having the same properties or different properties. The most important thing is the color and quality. And here, finally the station, we can have the station event, it can send a lot of events, and the station status. And with all those elements, let's say, we take them from CAMX. I went inside CAMX, it's a big standard, and it has a lot of schemas inside, and I made some analogy between the CAMX and my project. And actually CAMX is meant to be for electronic device manufacturing. So it's another case here, this is why I made this analogy. Here, first I need, after this, building this schema, you need to build something called wisdom document. The wisdom document is built on the schema. The first thing you need to build this schema, and this schema is consider types for the message. So over the schema you build something called message, and you put all these messages inside operation. Inside operation you can have one message or more than one message, and you put all of them also inside something called port type. And this port type has something called binding. This binding is a protocol which you are going to send you messages. And finally, you put all of them inside port. And inside every service, you can have many ports. And the implementation of web service, this all what we were talking about was like the software. We were talking about the software, but we thought first we need to put some controller. And this controller was S1000. It's some controller invented by Nico company, and for every station we saw, we attached or we made hard wiring between the PLC and between the S1000 to make this kind of conversion from normal bits or the physical layer to some web service. And finally, you are going to download some WSDL file over every one S1000. And this is finally going to be something like what we did. We have network, and finally you can monitor everything from the network itself. Actually, it could be the internet itself. And this is the result for everyone. This is only one station. So inside every NICU you can see the result after you download the services on it. And this was some just shortcut. It's at one moment you can see all these events. And actually you define the neighbors. So define the other station inside the S1000, but also you can see all the devices together in something called web service discovery or web service. It's kind of monitoring system. So here, this is what I was talking about. You have all the stations here, the 6 stations, and you can subscribe which service you need from every station, and you are going to find him. We are going to find them here whenever these services are going to be allowed. This was the first part of my master thesis. The second part is designing of expert system. The same thing also, I'm going to start with the definition. The definition of the expert system is a computer program try to mimic, I'm going to say it with my language, try to mimic the expert knowledge, or try to mimic the expert human. It's a kind of artificial intelligence. You get all the expert knowledge and reasoning, and you try to put it into software shell. All right, and this is how. What is this, the expert system composed from? There is some expert which is updating some knowledge base. This knowledge base can be with any language, and then you have the shell itself. In our project, we used some software called rules. In rules, you are programming it with Java. So the shell itself has some knowledge base and is communicating with the outer knowledge base. And you have something called reasoning engine. This reasoning engine is a kind of brain which is reasoning the facts and get new facts, and it updates again the knowledge base, and it's kind of learning the system itself. And finally, you have the user interface, which is user seeing the output results from. And to program this expert system on the business, from the business point of view, we need to have something called KPI, key productive indicators. And here I had some of them, like I have 10 here. It's all of them like related to the rate of defection, related to like if you have some defective product, if you have some undefected product, also need to get the rate per hour and per target. This target is the number of products you need them per hour, for instance. Also, I counted black and non-black per hour, and you need to get other KPIs based on those ones. So here we didn't use machines themselves for sending the XML messages. We used something called a client. It's kind of simulator for the machine. Here you just put the address of the root of this expert system or reasoning engine, and you put your own message, which is the same message which we already have it inside our web service. And here the engine itself should take these messages, and every 1 hour it should show some results, like this KPIs we already discussed. And finally, this is my conclusion, that ESA 95 model can fit modern automation system. CAP-X standard is meant for exchange manufacturing equipment for electronic devices, but also you can make some energy and use it for another subjects. Web service can be a good technology for upgrading the old automation system, and the root is a good reasoning engine for an expert system which is dealing with XML messages. For future work, I'm going to, if I would have a future work with this project, I would try to make more better graphical interface. As you can see, we have only some black server, but also you can use Java a bit for making some graphical interface. We are going to test the XML messages on the real machines, not on this simulator. I'm going to search for more KPIs and try to program it for this rule, and expanding my rules for a new case study. And this my references, some of them for sure. And finally the questions, please.
Thank you.
I have something to show. I can show you this thing. If I have
You have
like 2 minutes.
3 minutes, yeah.
Okay, so this is the server. Here I have this. I already started it. I have this fiddler here. You just need to take one message of those and put it inside the fiddler. We need to post it. We need to just give him address of root. And then you need to execute, okay, and execute many things here. And if we open the server now, we are going to find it's like getting some messages already. I tried to show both of them together. I need to monitor it. Let's see. So here you can try here to change also, like any parameter inside. You can go and put it as black, and you can put here as workpiece is okay, not affected. Okay, right. And you can send again and this receiving and counting. And it should be per 1 hour, but I put it only 90 seconds because I know it's going to take this time here for 1 hour. But after 90 seconds, it should give us like, it makes some reasoning and sending us the final results. And you can ask until it will get us final results.
Thank you. So Let's
Questions?
open the floor for questions. And I think
you
the
can see the
solution
results
has
here.
been to have a question or comment from all the attendants. So if you start from here and go around, and for the next presentation, making the reverse order then.
Okay, so maybe I could ask about the KPIs that you are using it. Do you extract them from any kind of standard or you create your own KPIs?
Yeah, I get them from some business books. I went to some business books and I was trying to see which criteria are important for the management level. But I didn't create them from my mind. They have some laws actually. I just got the laws and put them inside my rules.
Okay, and just a general question, which benefits do you think that this work done in your thesis has for a production system?
To have an expert system is something good because maybe if you have a real expert human, he can leave you in any moment, and all the knowledge he have is going to be gone. Also, the system itself is like learning itself, so you don't lose actually any data, and it can be used for like for training. Actually, it can be used later for training the other people to have some human expert from it. It's the advantage of the expert system. It has a lot of other advantages, but I don't think we have time for it.
Okay.
You have said that we have been using this web service technology,
Yes.
but web service is software technology, right? You have been placed it on devices.
Yes.
In which way and which implementation of this technology have been used for it, or how it happened? How it happened that your devices were able to expose these web services in network, not being a computers, is like being simply controllers.
Okay. I cannot get your question. You have something called UDDI. UDDI. It's kind of protocol. When you program the web service, you adjust this protocol to publish with time your service over the network.
I mean that, yeah, you programmed, but how the device exposes all this information to network? I mean, does it implement some kind of standard industrial one, or I mean, is this devices can you use only Inico for these purposes, or can you use some different devices? But which standard they should have?
You can use different devices for sure. But
Okay.
Inico is designed to. I don't know exactly the know-how of this device,
Mhm.
but for sure you can program web service over a regular computer, not over S1000.
Okay. Yeah, that was kind of question that I wanted.
Yeah. But it's more about the know-how of this device. So inside it, you just program it, and I don't know exactly how it's publishing it. If this is your question.
Okay, yeah, clear.
So as long as as far as I understood, you can just, as long as you have S1000 installed in your line, you can just expand it, or it's what exactly do you need to implement this? For example, in Factory, and not only in this festival.
I need it's a S1000 here only work like take the data, the physical data, like let's say the action of the PLC itself, either the action or the sensor data, and it convert it. I mean, I take it inside this S1000 and I program the S1000 to convert all this data to web service form. So it's more like working as a converter here. It's not controlling anything from the process itself. And this was the target of the thesis. You don't need to destroy anything because you can just go and use this S1000 as a controller, but you need to stop the work, and you need to pay money for programming the S1000 itself for the new process. So it's better to use it this way.
For me, it's more like technical question about the service mix and this rule.
Yes.
Why rules? Because maybe it's
Because it's open source.
open source.
Yeah, but there is a lot of other,
Okay.
and it can easily work with XML messages also.
Okay.
So there's a lot of other reasoning engines.
And you can integrate everything.
Yeah.
And how you store the messages? You only receive the message and
This is
calculate?
something I need to also store them.
Yeah.
It's an instance. If you are talking about the result, not the messages, I was thinking later I need to have a database and
Okay.
put all the result inside a database, but
Okay.
it's just an instance. It's a
Okay.
kind of local data inside the tool itself.
Good.
Yeah.
So, what was the motivation behind this? Why you doing this to do?
Finish my master.
So, you were doing to achieve some task in your lab.
It's it's a project, as I said. It's a kind of project, and there is really famous apart from this project. I think Schneider Electric, BMW. There's a lot of people trying to search in this topic now, and it's just a case study here. I mean, I'm not doing something really in wide range. I'm doing something to prove that this thing can be done, and they are going to implement it in different way for sure. This was the motivation. So was I getting
Possible
it?
applications to see.
The same problem statement. It's like if you need to convert the whole technology from DDC to technology which we are using now over the networks. So, for instance, you can now you can attach all your service to your internet, and you can monitor your system from another place.
I think the presentation was good, it's really nice, and explained very well. I have one question that you are running that your application on some platform or some server. So what was the server? I mean,
It's
it was Apache or
Apache service.
Glassfish?
Apache services.
Apache 7.
Yes.
Apache 2, okay.
And thank you.
I have a couple of small comments and a couple of general questions. Yeah, I also agree that in general the presentation was clear, and I think the slides as well. Sometimes you had maybe a bit too much text.
Yes.
Yeah, like too long sentences, and then when we start to read, we kind of miss off your what you are saying. But I think overall
I
it was
put them
good.
in purpose, like I usually put definition and I try to say it myself. So in both way, like the listener can listen to my definition and also he can read the definition. I mean, I'm not like memorizing it.
In general, I think it was good. Then, okay, the objective was clear, so you made a clear problem statement in the beginning. So that was very good. But what kind of I didn't get in the presentation, and what I'm missing, that what is this compared to the state of the art? Is this something that there's a lot of similar work going on? Has this been done before, or is this totally unique? That the comparison to something that is existing or parallel going on in the other research labs? And so this is something that I didn't get from this presentation. Probably it's in your thesis, but in this presentation,
Alright, it's not in my thesis, but I can answer you. It's like there's a lot of people using expert system, a lot of people using web service, but there is not a lot of people try to integrate them together.
okay, something like this maybe in the beginning would be good because it would give the novel
I
chance.
know that I had a lot of slides, so I tried. Even I was like trying to finish it so fast.
Yeah,
This is why I couldn't need it.
and then other comment, it's related to the expert system. So also it was not very clear to me that what is actually the expert system or what is the knowledge base that you are using. So now it seems more that you are calculating the numbers, the key parameters, but is there some
Yeah,
real...
the knowledge base itself is those objects I showed before. You need like always to have those objects.
Sure.
Yeah. So when you send a message called workpiece, the expert system itself need to know that this is the workpiece, and they need to count it.
Yeah, this is kind of the basics what needs to be there. But then when you say that, for example, the expert system can be for learning and for teaching,
Yeah.
so it's not so clear, at least not to
Right.
me. What kind of learning
It's
and how are going to use this?
You can, for instance, know the average production rate, or like whose time you can expect what is going to, from all the data, you can expect what is going to be in the future. Like for instance, if you have like 1 year, let's take it in another expert system, not this one. If you have like air conditioning, for instance, expert system, it can from the previous year knows that this year at this moment the load is going to be high, for instance.
Yeah.
So it's by expertise knowing that, or from the past is knowing that this is going to happen. It
Yeah,
should
I
be something
yeah.
like this here, but it's not, my expert system is not that complicated to do this task now.
Okay, so because of course I understand what is the expert system in general, but I just didn't see the features in here.
Yeah. I got what you mean. I just want to say it's like can be done, but I didn't make it.
No.
I didn't make it very complicated. As I told him, it's just like a case study. It's not something really we are going to admit as it is in reality.
Okay, but very good. Yeah, thank you. So let's stand down here and move on to the next presentation.